Okay, welcome to factoring the expression ax squared plus bx plus c. So we're talking about factoring quadratic expressions. Specifically today we're going to talk about factoring when this a value is other than 1. So this can get more complicated, and we're going to go through several examples where we see larger a values. Okay, so in the first slide here I've kind of demonstrated on the 4 steps that I would use each time we factor this expression. So number 1, you have to multiply a times c. Okay, so this term times this term. Be careful though, make sure there's no common monomial first, so meaning these 3 numbers are not all divisible by 2 or 3, so make sure there's nothing common to all 3. If there is, factor first, but if these are all uncommon terms, then we're going to go ahead and first multiply a times c. Once you do that, there's 2 things you're looking for. You're looking for 2 numbers, m and n, where the product m times n is actually equal to a times c. Then m plus n has to equal that b term. So this is really important. Once you figure those 2 numbers out, m and n, if it's possible, we're going to replace the bx term with m and n from number 2. So the last step would be to factor the new expression by grouping. Okay, so this last step is a little more tricky. We're going to factor by grouping. So to factor this expression, we have to use another method called grouping. So these are the 4 steps that we're going to use to help us factor ax squared plus bx plus c, and again, when that a value is greater than 1. So our first example is asking us to factor 5x squared minus 17x plus 6. So I've listed the steps out, and let's go ahead and start. Number 1, I'm going to multiply a times c. Reason being, 5, 17, and 6, there's no common number I can factor out of those. They're not all divisible by 2. They're not all divisible by 3 or 4. So there's nothing common. No single term I can factor out. So we're going to start number 1, a times c. 5 times 6, that's 30. So again, what this in red says is that we're looking for 2 numbers whose product is 30, whose sum is minus 17, negative 17. So I think about it, well, 2 numbers that multiply to be 30 are 15 and 2. Negative 15 times negative 2 is 30. Negative 15 plus negative 2 is negative 17. So I found my 2 integers, negative 15 and negative 2. In the 3rd step, they ask us to simply rewrite the expression and then factor. Here's my original expression, 5x squared minus 17x plus 6. Notice how this middle term is in red. Let's look at it when we rewrite that expression with our m and n. 5x squared minus 15x minus 2x plus 6. These 2 expressions are the same. Negative 17 is equal to negative 15 minus 2x. So this was step 3. Step 4 says factor by grouping. So in step 4, notice how I put the 15x term with the 5 and 2 and 6 together because we have common terms. So what's common between 5x squared and minus 15x? 5x. So I factor out the 5x here. What's remaining is x minus 3. 2x plus 6, a number that's common between 2 and 6, is 2. So I factor out a 2, and I'm left with x minus 3. In the last step, what you should notice is that I have 2 terms underlined in red that are the exact same. Here is one term minus another. Both terms have something in common. It's x minus 3, so I factor out the x minus 3, and 5x minus 2 is what's left. A quick trick: whatever's in parentheses will be one factor. Whatever's outside parentheses would be the second factor. So that's how we factor 5x squared minus 17x plus 6. So let's look at another example. So we're going to factor 3x squared plus 20x minus 7. Again, I look at 3, 20, and 7. Nothing common between all 3 terms, so I'm going to start by multiplying a times c. 3 times negative 7 is negative 21. In step 2, now I have to find 2 integers whose product is negative 21, whose sum is 20. So I think, okay, negative 21. So if I do 21 times negative 1, I get negative 21. 21 plus negative 1 is 20. So I found my two integers, and notice how the signs on these numbers are m and n are exactly the same in both expressions. They don't change. So I've got my two numbers, 21 and negative 1. In step 3, we go ahead and rewrite our original expression. So we have 3x squared plus 20x minus 7. Again, I put that b term in red because we're going to change that. So now we have 3x squared plus 21x minus x. I rewrote our expression using our m and n. Now, careful with the way you align these. Notice how I put the 3 and 21 together because they have a common factor of 3. And I put the 1 and 7 together, the x and the 7. So here's my rewritten expression. Now we factor by grouping. So we go up to step 4. And I look here and I say, well, what's common between 3x squared and 21x? Well, the term 3 and both have an x. So I factor out 3x, and let's look at what's left. Okay, 3x goes into 3x squared x times, 3x goes into 21x 7 times. The second part of this is a little more tricky. Nothing's common between 1 and 7, okay, except for 1. But they both have a negative. So the only thing I'm going to do is I'm going to factor out a negative 1. So I factor out the minus, okay, and then I'm left with x plus 7. Again, look at what's underlined in red. Two terms, both having x plus 7 as a factor. So remember what we said in the last slide. They both have the same factor here. What's in parentheses is one factor. What's outside is another. 3x minus 1 is the other factor. Now, can every quadratic be factored? The answer to that is no. That's why we have other methods like completing the square or even the quadratic formula to help us solve quadratic equations. That'll come later on, but here's an example where I want you to factor 2y squared plus w, or excuse me, 2w squared plus w plus 3. So 2, 1, and 3, nothing common. So I start multiply a times c, which is 6, 2 times 3. Two numbers that multiply to be 6 and add to be 1. You would think, okay, 3 and 2. But you can't get positive 1 out of that. This combination of integers where the product is 6 and the sum is 1 is just not possible. There's no two integers that will give us that. Okay, that's the thing. No two integers are going to give us positive 6 when you multiply them together and a sum of 1. Okay, so this is what we would say is not factorable. It doesn't mean that this graph, if we graph 2w squared plus w plus 3, wouldn't have zeros. But it's just not factorable. Okay, so let's continue on and look at another problem. Factor 12x squared minus 28x minus 24. So every problem so far we've started with a times c because there's nothing common to all the terms. But if we look more closely, each term here is actually divisible by 4. So I'm going to go ahead and factor out the 4 first. So here's our original expression. Factor out the 4. Okay, 4 goes into 12x squared, 3x squared times. 4 goes into negative 28x, negative 7x times. And 4 goes into negative 24, negative 6 times. So I've factored out the 4, I've factored out the largest common term. So when I look here now, I have to go ahead and factor what's in parentheses, or try to. The whole idea is to factor that expression. So I'm not done. Okay, I factored out the 4, that's true, but I have to see if this is actually possible. Can I factor 3x squared minus 7x minus 6? So I have to try to completely factor this as low as possible. So again, I start with our rules. I multiply a times c, and I get minus 18. So now I'm looking for two numbers whose product is negative 18, whose sum is, that should be negative 7 there. Okay, so let's look to see if we can get that. Two numbers that multiply to be negative, well, it should be negative, yeah, negative 18 and add to be negative 7. So that's a mistake there. So just remember that's minus 7. Okay, so we have to see if this is possible. So I take negative 9 and 2, and I get negative 18. And then if I add negative 9 and 2, I get negative 7. So I do have two numbers that work, m and n. So this is factorable. So I've ignored the 4, and I'm going to just bring it out front. And here's my expression. 4 times the quantity 3x squared minus 7x minus 6. Again, my bx term is in red. Let's just rewrite the expression using our new m and n. So 4 times the quantity 3x squared minus 9x plus 2x. In red, that total, that sum is actually negative 7x. Okay, and then we subtract the 6. So these two expressions are equal. I've just rewritten it again with our m and n. So now you've got a factor by grouping. So two numbers, if we look at the first two terms, 3x squared minus 9x, 3x is common. And when I factor out the 3x, I'm left with x minus 3. 2x minus 6, common factor is 2, and I'm left with x minus 3. So again, whatever's in parentheses is one factor. Whatever's outside the parentheses is our second factor. And the 4 comes along for the ride. Okay, so the final product here is 4 times the quantity x minus 3 times the quantity 3x plus 2. So this is how we factor ax squared plus bx plus c when the a term, the leading coefficient, is greater than 1. If you have any questions, you can post them below, or you can email me at nicholas.bennett@dc.gov. Thanks, guys. We'll see you next time.